Welcome to our first video of the course. Thanks for making time to view this video, and I hope that you will take very careful notes of the video, and then make note also of any questions you have during the video so that I can answer those questions when we meet in class. This video is going to cover our first section, the review of functions. Section 1.1, Review of Functions. The first topic I'd like to discuss is finding the domain and range of a function. So excuse the mess it may look like here on the screen. I've tried to do some of the work ahead of time so that it would make the video go a little bit more quickly. If you need to, if I'm going too fast, you can always hit pause and rewatch the video. But what we're going to do is look at this example, find the domain of the function f of x equals the square root of 7 minus x squared. Well, the important thing to notice about a radical is that if there's an even index, and when I read this I said square root, it's implied that there's an index of 2 in here. And if it's an even index, so if this was a 4th root, 6th root, and so on, then you'd follow this same procedure because the radicand, that's the piece that's inside the radical, that's this, the 7 minus x squared, has to be greater or equal to 0. And that's only if this index is even. So if this is a cube root, we can have all real numbers in most cases. But here, since we've got an even index, it's a square root, the radicand has to be greater or equal to 0. So that means the 7 minus x squared is greater than or equal to 0. And if I solve this for x, I would subtract 7 from both sides to get the opposite of x squared is greater or equal to negative 7. And then I'd want to divide by negative 1. But remember, when you divide by negative 1, that greater than or equal to has to shift, has to flip to be less than or equal to. So I get x squared is less than or equal to positive 7. If I took the square root of both sides, I'd get the square root of x squared is x is less than or equal to positive or negative 7. So in other words, x must lie somewhere between negative 7 and 7. So in interval notation, I could say that the domain is the closed interval from negative 7 to 7. So that means that the negative 7 and 7 are both included. Another type of domain question that we might have is a rational function, such as this f of x equals 3 minus x over x minus 9. Recall that for a rational function, so that's something that's written like a fraction, recall that the problem area is that denominator, the bottom. Remember that for a fraction, we can't have a 0 in the bottom or in the denominator. So for this example, we would get that the domain is anything such that x minus 9 is not 0. If I solved this for x, I'd add 9 to both sides, and I'd get that x can't equal 9. In interval notation, I'd write that negative infinity to 9 or 9 to infinity. Let's look at another type of example, the composition of functions. This is all a review of what you should bring in from pre-calculus, but if you didn't remember a part, that's okay. Make sure you take the time you need to review this. But if you recall, if I wanted to compose the functions f and g, that means f of g of x. So it means that I'm going to take the g function, the x squared minus 4, and I'm going to plug that in to the x to the f of x function. So it would look like this. F of x squared minus 4, I would take that x squared minus 4 and put it inside the f function. So f of g of x is the absolute value of x squared minus 4. One more time, the steps that we follow. This second function, the g, is always going to be what we work with first. We put that g of x in first, the x squared minus 4. And then we put the x squared minus 4 into the f function. So that's an example of composition of functions, just a quick review. Let's look at a quick review of a difference quotient. Now this might be a new name, but you've probably simplified things like this. So let me show you what an example might look like that asks us to simplify something with a difference quotient. This is going to be a very important algebra review. Please make sure that you're very comfortable doing this type of problem. What this means, and let's take this number 64 as the example we'll do. What this example means to do is replace the x with x plus h, and then replace f of x with f of x and divide by h. So it would look like this. Now I'm going to use a different color for the f of x plus h, and then a different color for f of x. But f of x plus h, if we're doing number 64, that would be 4 times, in place of x, I'm going to put x plus h, minus, and then for f of x, we'll have 4x minus 3. Notice I put parentheses around that 4x minus 3 because we're subtracting the whole f of x. So we have to subtract 4x and subtract the opposite of 3. And then I'm going to divide all of that by h. So working this out, simplifying, I distribute the 4, distribute the negative, simplifying 4x minus 4x, that cancels out. 4x minus 4x is 0, and I'd have 4h. Oh, you know what? I'm so sorry. I just noticed when I did this 4x plus h, I got carried away too quickly and left out that minus 3. So notice I should have had a minus 3 in there. I was looking for that because I knew that 3 was supposed to also cancel out. But this minus 3 plus 3 cancels. So what are we left with? We're left with 4h. Any farmers out there? 4h divided by h, or just 4. Now I apologize for this error I made here. Let me go back and make sure everyone follows what happened. When we did f of x plus h, I replaced the x with the x plus h, but we've got to keep the whole piece, so that 4x plus h minus 3. So we had 4 times the quantity of x plus h, quantity closed, minus 3, minus 4x, minus negative 3. The negative 3 and the minus negative 3 canceled out. The 4x and the minus 4x canceled out. We were left with 4h divided by h. The h and h reduced or divided, so we're left with 4. I want to show you, just because this is such an important example, I want to show you one other way that you could show this problem. And if you ever get hung up with the algebra, then this next way of showing it might work best for you. I'm going to write instead of writing this as a fraction, I'm going to put the f of x plus h in. And simplify that. So we have our 4x plus 4h minus 3. And then below that, I'm going to put the f of x. And I'm going to put it right below it, and right below each of the pieces that match up. Now, do you see what's going to happen when I subtract these? When I subtract that, it means subtracting the whole thing. So that's the same thing as adding the opposite of each of those. So there's something about writing these vertically above each other that clears up any algebra problems, because 4x minus 4x is clearly 0. 4h just carries down. Negative 3 plus 3 is clearly 0. So we're left with 4h. And then I go back with that 4h and I put it over h. That's that last part. To get the h divided by h is 1. So to get the answer 4. But this might help if you have any trouble at all with the algebra when you get to these examples and it's just not working out. Go back to this video, watch this one more time, and try it like I showed in that last example. Well, we're down to just one more example that we need for this section, and this is an example I'd like to walk you through, a review of even and odd functions. I've just copied and pasted the definition right out of our book. To show these algebraically, we can show that a function is even by showing that f of the opposite of x is equal to f of x. To show that it's odd, we'd show that f of the opposite of x is equal to the opposite of f of x. So let's take an example like this. F of x equals, oh, I'm sorry, I already wrote it. F of x equals 3x to the fifth plus 2x cubed minus x. And if I want to find f of the opposite of x, notice that that's what we do for both the definitions. If I want to determine if it's even or odd, I'd replace the x with the opposite of x. The way I go about doing that, if you could look at the black and ignore the pink for just a minute. If I wrote that f and then left this as an empty parenthesis equals 3 empty parenthesis to the fifth plus 2 empty parenthesis to the third minus empty parenthesis. What I've done is I've just replaced each of these 3 x's with an empty parenthesis. Each of these 3 x's had an empty parenthesis. And then what you do next is you go in and you replace each of the empty parentheses with that opposite of x. Well, negative, or the opposite of x to the fifth power, is still going to be negative. So this would be negative 3x to the fifth. The opposite of x cubed, that's still going to be negative. So minus 2x cubed minus the opposite will be positive x. And when we compare this, we notice that our f of x and our f of the opposite of x have the same terms except that they're different signs. 3x to the fifth, 2x cubed, x. But instead of being positive, positive, negative, we have negative, negative, positive. So we can see that f of the opposite of x is the opposite of f of x. What I'm doing now might look like I'm just simply factoring out the negative, and that is what I've done. Let's factor out the negative, so this becomes positive, factor out the negative, this is positive, factor out the negative, this becomes negative. But what we recognize here is that f of the opposite of x is the opposite of f of x, so that's very odd. When we replace the x with the opposite of x and we get exactly the same thing back except negative, that's really odd, isn't it? And we would call that an odd function. And that wraps up our short video here. I hope you found these examples easy. If you need to, if it went too fast, pause the video, go back and watch it again. But please be certain to write your questions on your notes and bring those with you when you come to class, because I am happy to answer any questions you have in class.